Hey guys, today we're going to look at 7A Part 2, still looking at properties of polynomials. Yesterday we looked at the end behavior and the domain and range of polynomials. Today we're going to look at where polynomials have what we call a maxima and a minima. A maxima is when the graph switches from increasing to decreasing, so it has like a high point, and a minima is when it switches from decreasing, so going down to going up, so it has a low point. We're also going to be looking at how to write when is a graph increasing and when is a graph decreasing. We are going to need a graphing calculator, so I've kind of split screened our notes today with the graphing calculator. If you'd like to bring up the graphing calculator on your own laptop, that would probably be a good idea. Otherwise, try and follow along. So looking at example 1. The first thing it asks us for is a maxima. So your maxima is where your graph has a high point, right? And it doesn't need to be the highest point. It's just a point higher than anything around it. So actually this point right here is our maxima for that. So this point, is over to 0, like up and down 0. This point is at 2, 0. Our minima is a low point, right? So again, it doesn't have to be the lowest point on your graph, but it's going to be lower than the things around it. So for example, right here, and let's just call this -1, -4. I'm rounding a little bit, but that's okay. We also have one right here. We'll call that for -1. Okay? So that's just your maxima and your minima. Then we want to know when is this increasing and when is it decreasing. Okay? To find when it's increasing and decreasing, we use interval notation, the same notation we use when we write domain and range. So we have to know when does it start increasing and when does it stop increasing, when does it start decreasing, when does it stop decreasing. One of the easiest ways to start getting used to it is to draw arrows the way you would draw your graph. Graphs always start on the left and go to the right. It's just like reading a book, right? I'm going to read going this way to this way. So I'm going to start at the leftmost point of my graph, right, the left end. And if I was to draw my graph, I'd be drawing arrows that way, right? So you can kind of follow the arrows around. So it's increasing anytime the arrows are going in a slightly, even just slightly, upward direction. And the thing to remember about our definitions, is maximas and minimas are where they switch from increasing and decreasing. So you can use your maximums and your minimums to see, to help you know like the stopping points. Because I can see I'm increasing, right, my arrows are going up right through here. So I have a starting point and a stopping point, right? My maximums and minimums help me define what those points are. One important thing for increasing and decreasing, we only look at x values. X values are the only thing we look at. Do not use y. I will say it till I'm blue in the face, and some of us still will. So just remember that. No x values ever. Or sorry, no y values ever. Sorry. Only x values. So if I look here, I start here. My x value here is -1. Then I go to here. My x value here is 2. So it's increasing between -1 and 2. There's another spot where my graph is increasing over here, right? My arrows are going up. So I'm going to put a little U. The U stands for union. It's kind of like and in notation. Then I start increasing here, which we said was 4. And I never stop increasing. And so then it goes to infinity. This is infinity because my x value is going to the right. It is not because it's going up. Up would be my y value. It's infinity because it's going this way, right? It's going to the right, the positive infinity. All right, now let's look at decreasing. I am decreasing, right? My first section that I'm decreasing is here. Same type of thing. It's always decreasing until I get here, right? So I'm decreasing forever until I get here. Again, we're looking at our x values. So my x value in this direction is negative infinity. And then again, it stops decreasing here, which is negative 1, he said. And that's union with, we have another spot, it's decreasing. It's decreasing between these 2 points. So that's 2 to 4. And that's it for the increasing and the decreasing part. Again, we're using the x values, right, from our minimum and maximum. Those are the only numbers we use. And then infinity and negative infinity. All right, let's look at another example. Looking at C. First, deciding where my my maximum is, the highest point. The highest point seems to be right here. Let's call that negative 2.5. And it goes up to 1, so negative 2.5. And that's my only maximum, okay? That's the only, high point. Kind of can refer to them as peaks and valleys, right? That's a peak. Minimums would be our valleys, right? Our valley could be right here, and that is at 0, negative 6. Then I need to draw my arrows as I go around my graph. So now, when is it increasing and when is it decreasing? So if you look, I have 2 different sections where it's increasing, and I only have 1 section where it's decreasing. So it's going to start increasing on the right. My x values on the left. My x values on the left side of my graph are negative infinity. And then I go up until I get to that negative 2.5. Again, union. The next time I start increasing is down here. My x value there is 0. And I'm going to keep increasing forever. And my x values on the right side of my graph are infinity. For decreasing, there's only one spot that I'm decreasing. I start decreasing here at negative 2.5. And I stop decreasing here at 0. And again, only ever looking at x values. All right, let's look at C. Now with C, now we don't have a graph, we just have an equation. That's where we're going to come to our calculator. From the home screen, I'm going to open a new document, and I'm going to add a graph. So my graph is negative x to the 4th. Make sure when you type an exponent, you hit to the right one so that it's no longer typing in the exponent spot, plus x squared plus 2. So for the graphed ones, you have to give the ones where you have your calculator. You have to give them to me exactly. Right? So we're going to use our calculator to find that minimum and maximum. The first thing I'm going to do is I'm going to scroll over here, and I'm going to hold this. It should close that hand. It doesn't always do it on the computer. But if you're on an actual calculator, if you click and hold this button, it will close the hand, and you can move where that function says. So you can read everything better. So then, menu. And we're going to go to Analyze Graph. So let's write that in our notes. And then it's 6. Analyze Graph. And then we can either choose 2/3, which is min or a max. Okay, so you're going to be choosing one of those. So let's do our minimum first, because that's the first one that pops up. So I'm going to look at my graph, and I want to slide this over so that it's just to the left of the minimum. Press Enter. Only hit enter once. It doesn't really change. The only thing that changes is down here in this corner. But then I'm going to slide to the right. Enter. And this one's a little bit weird. Anytime you see some number like this, and like an E and a negative 10, it really means 0. The calculator just got confused. So, our minimum is going to be 0, 2. Now looking for our maximum. So menu, analyze graph. I'm now going to look for my maximum. And again, there's 2 of them. I got to do each one at a time. So I'm going to look for the left one first. Just to the left, hit enter. Just to the right, hit enter. And again, sometimes these are hard to read. So if you're on a computer, you can really just like use your mouse and pull it over. If you're on an actual handheld calculator, you gotta scroll over it and hold the button down, and it will change. And you can grab it and move it. And it makes it a little bit easier to read. So our maximum, one of our maximums is negative 0.707 and 2.25. Okay. Our next one, I have to do it again because I have another maximum here. Right. Scroll to the left, hit enter. Scroll to the right, hit enter. And I get 0.707, 2.25. So one's just positive and one's negative. So those are my 2 maximums. Now I want to decide, okay, where is my graph increasing and where is it decreasing? So it's the same kind of thing as I can't draw on this, but you can kind of think about it, right? It's coming up, going down, going up, kind of going up, down, to down. So it starts by increasing. So it starts increasing on the left. On the left is negative infinity. It stops increasing once I get to that first maximum, which was negative 0.707. Union. The next time it increases, right, is this little part right here, starting at 0 and going to 0.707. Now for decreasing, the first time it starts decreasing is at my first maximum, which is negative 0.707. And it decreases until it gets my minimum, which is at 0. Union with. It starts decreasing at my next maximum, which is positive 0.707. And it never stops decreasing as I go to the right. And to the right is positive infinity. And that's it. So for these, you really just have to graph them on your calculator. All right, for sake of time, we're going to skip D and move on to our next page. I'm actually going to get rid of this for now. We don't need our that anymore. Bigger. All right, so looking at example 2. Now I want to use the table to determine where any relative maxima or minima occur. Okay? So what we're going to do for these problems is I'm going to take this table and I'm just going to draw a quick sketch. Okay? So negative 1 is up 10. I'm going to say it's up there. 0 is at 4, about there. 1 is at 0, about there. 2 is at 2, which is about there. 3 is about 4, which is about there. 4 is 0, which is about there. And 5 is negative 14, which is going to be somewhere down here. Okay? So now, if I were just to straight connect these points, my graph would look something like this. Okay? And with a graph like this, I can easily say where my maximum and minimum are. However, I don't know if this is exactly my graph. I only know a few points. There's no reason my graph couldn't look something like that. Right? Now my maximum and minimum has changed. Okay? So for these problems, when you graph them, you can only be so exact with where your maximum and minimum are. Okay? So what we're going to do is for my maximum, this is where my maximum looks to be, right, at 3, 4. But I'm going to say, okay, I don't know if it's exactly at 3, 4, but I know it's going to be somewhere between the point before and the point after it. And again, we're going to use our x value. So I know my maximum occurs between 2 and 4. Okay? And again, this is interval notation. It's occurring between these 2 points. It's not saying it's the point 2, 4. It's occurring between 2 and 4. Same thing for my minimum. My minimum, right, looks to be about here. This is 1, 0. But again, I don't know if it's exactly there, but I know it's going to occur between this and here. Okay? So it's going to occur between 0, the x value, and the value I have behind it. And that's it. So for these tables, again, you can't be exact. You just have to give an approximate between for where your maximum and minimum is. All right, that is it for today. I'll see you guys tomorrow.